Hello children, welcome back to my channel. I am dealing with 10th class maths, similar triangles, 8.4 exercise. Exercise 8.4. In that 7 problems I taught earlier, now let me teach 8th problem. 8th problem is a 24-meter long wire is, it goes on like this, let me read this up. A 24-meter long wire is attached to a vertical pole of height 18 meters. There is a pole like this. For the pole, a long wire is attached and it has a stake attached to the other end. How far from the base of the pole should the stake be driven so that it will be a taut? That means a wire is attached like this. It has got some a stake to dig inside the earth. So where it has to pull and dig so that it will be in a straight line. That means we will be getting a figure like this. When it is fixed thoroughly, then the pole and the wire will be in this way. So let me consider AB is the pole and it is 24 meters long. A pole is how much? A 24 meters long wire. Wire is 24 meters long. Is attached to a vertical pole of height 18 meters. The height of the pole is 18 meters. So how far it has to be? What is BC? They are asking. So definitely it is a right angle triangle. In triangle ABC, angle B is equal to 90 degrees. Therefore, AC square is equal to AB square plus BC square. That means we want BC square. So BC square is AC square minus AB square. This is because of Pythagorean theorem. So this is nothing but AC is 24 square minus 18 square. So BC square is equal to A square minus B square, A plus B into A minus B. That is 42 into 24 means 16. 6. 6 if you take 6 plus 18, 6, 18 plus 2, 20, 24. So this is BC square. Now you want BC. BC is equal to root of 42 into 6. This can be written as 42 as 7 6 are into 6. So here 2 6's will come out of the root. Root 7 will be there. Therefore, BC is equal to 6 root 7 meters. Now the question is, how far the base of the pole should be? Should the stake? So the distance between the stake and the base of the pole. The base of the pole is equal to 6 root 7 meters. This is the answer, children. So what is given AB is pole. And this is, what is that they have given? Wire. Wire length is this. Okay. So write down this, children. This is 8th problem. Please note it down. Now, 9th one. poles of heights. It goes on like this. Let me read the problem. Two poles of height 6 meters and 11 meters stand in a plain ground. There is a ground upon that two poles are standing. One is 6 meters and one is 11 meters. If the distance between the feet of the poles is 12 meters, find the distance from their tops. So you have got two poles. One is 6 meter and the other one is 11 meters. So definitely it will be more. So let me take AB as 6 meters, CD as 11 meters. The distance between them is how much? The distance between them is 12 meters. Now the question is, find the distance between their tops. That means, what is AC? They are asking to find out what is AC. Here you have got a construction, children. What is the construction? You have to draw AE. AE parallel to BC. Okay. AE you have to draw. This is parallel to BC. Draw AE parallel to BD, not BC. E lies on CD. Now, if this is 12 meters, definitely this also will be 12 meters. Now, let us take triangle ACE. In triangle ACE, angle E is equal to 90 degrees. Therefore, AC square is equal to CE square plus AE square basing on Pythagorean theorem. Now AC we don't know. AC square is equal to CE. What is CE? Totally it is 11. This whole length is 11. From 11 you have to subtract 6 whole square plus AE. AE is 12 square. So this is 5 square plus 144. 5 square is 25 plus 144, 169. Therefore, what is AC? Root 169, that is 13. So the distance between the tops of the poles. The distance between the tops of the poles is equal to 13 meters. Is the answer, children. Please note it down. This is 9th sum. Now 10th one. In an equilateral triangle ABC, D is a point on BC such that BD is equal to 1/3 BC. Prove that 9AD square is equal to 7AB square. This is the problem, children. That means you have got an equilateral triangle ABC. You have to draw. Figure is not given. You need to draw an equilateral triangle ABC. And what did they say? D is a point on BC. Let me take D here. D is a point on BC such that BD is equal to 1/3 BC. So, you have to join A and D. Now, what is RTP? 9AD square is equal to 7AB square. You have to prove. For this also, you have a construction. Construction is draw AE perpendicular to BC. So, what you have to do? You have to draw AE perpendicular to BC. Now, let us see the proof. 9AD square. First, you find out what is AD square. To find out AD square, what you have to do? You should take triangle ADE. In triangle ADE, angle E is 90 degrees because of our construction. We have constructed. Already I told you, children, in an equilateral triangle and isosceles triangle, altitude and median are one and same. So, AE is perpendicular to BC means E is the midpoint of BC. So, in triangle ADE, angle E is 90 degrees. So, what is AD square? AE square plus DE square. This means AE square plus what is DE? DE means BE minus BD whole square. BE minus BD will give you DE. That means AE square plus BE square, A minus B whole square, plus BD square minus 2 into BE into BD. A square plus B square minus 2AB. Now, here is children, AE square plus BE square. AE square plus BE square is AB square. So, in that place, instead of this, I am writing AB square plus what is BD? 1/3 BC. So, I will be writing 1/3 BC whole square. What instead of BD? Minus 2 into BE. BE is half of BC. BE is half of BC into BD. BD is once again, what is BD? 1/3 BC. They have given 1/3 BC. So, this is equal to AB square plus 1/3 BC square can be written as, in the place of BC, I can write AB. Why did I do it? Because it is an equilateral triangle. AB and BC are same. So, I can write it as AB/3 whole square minus 2 and 2 will get cancelled. Instead of BC, I will write AB into, instead of BC, AB/3. Here I will write because BC is equal to AB. This means AB square plus AB square by 9 minus AB square by 3. So, here LCM is 9. 9AB square plus AB square minus 3 3s are 3AB square. That means 9 plus 1, 10AB square minus 3AB square by 9. 10 minus 3 is 7. AB square by 9. So what are we getting here? AD square. This is AD square, no? So AD square is equal to 7AB square by 9. That means 9AD square is equal to 7AB square. This is what they asked you to prove, and we have proved, children. So in this case, since they have given ABC is an equilateral triangle, we could take in the place of BC AB. And BD is 1/3 BC they have given. So in the wherever BD is there, I have written 1/3 BC. Okay. BE means half of BC. That is why there I have written half of BC. I hope I am clear, children. Please note it down. Now, let us see 11th one. 11th one, they have given a right angled triangle. This is a right angle triangle, that is A, B, C. It is 90 degrees. 11th problem here. And D and E. D and E are points. This is D and this is E. They are trisecting. So I will read the sum, children. So let me first finish off drawing this figure. The figure is in this way. This is the figure given. In the figure, ABC is a triangle, right angle. ABC is a triangle, right angle at B. Right angle at B. D and E are points on BC. Trisect it. D and E are points on BC. Trisect it. Prove that 8AE square is equal to 3AC square plus 5AD square. This is the proof. This is the problem, children. So 8AE square is equal to 3AC square plus 5AD square. So let us see here. Let us go for LHS. LHS is AE square you want. AE square means first you take in triangle ABE, angle B is 90 degrees given. Therefore, AE square is equal to AB square plus BE square basing on Pythagorean theorem. Now in this, what happened, children? D and E trisect, they said. What is that trisect means? It is dividing into 3 equal parts. So let me consider this as x, this as x, this as x. So what is AE square? AE square is AB square plus BE. That means 2x whole square. That means AB square plus 4x square. Now LHS, what you want? 8AE square. 8AE square is equal to 8 into AB square plus 4x square. That is 8 AB square plus 8 4s are 32x square. Therefore, we have got 8ae square is 8ab square plus 32x square. This is what LHS I have done. Now I am going to RHS. In RHS, I have got 3ac square plus 5ad square. So first I will take AC. AC means I should take a triangle ABC. In triangle ABC, angle B is 90 degrees. This is given to us. Therefore, AC square is equal to AB square plus BC square basing on Pythagorean theorem. That is AB square plus, what is BC children? X plus X plus X, that is 3x whole square. That means AB square plus 9x square. What is it? AC square. You want 3AC square. 3AC square is equal to 3 into AB square plus 9x square, that is 3 AB square plus 3 9s are 27x square. 3AC square means this we are getting. Consider it as the first one. Now, we take AD. AD means you have to go for a triangle ABD. In triangle ABD, angle B is 90 degrees. That is given to us. Therefore, AD square is equal to AB square plus BD square. AB square plus BD square. That means AB square plus X square. BD is X. AB square plus X square. That means how many ADs you want? 5 ADs. 5 AD square is equal to 5 into AB square plus X square. That means 5 AD square is equal to 5 AB square plus 5X square. Let us take it as second equation. So, first equation plus second equation. First equation LHS is 3AC square plus 5AD square is equal to, this is how much? 3AB square plus 27x square plus 5ab square plus 5x square. Means how much I am getting? 3ab square, 3ab square, 3 plus 5, 8ab square plus 32x square. See children, RHS I got 80ab square plus 32x square. LHS also I got 8ab square plus 32 square. Therefore, we will be saying that LHS is equal to RHS. Therefore, 8a square is equal to 3ac square plus 5ad square. Hence, proved. This is the proof of this 11th sum, children. Now, go through it. Now, 12th sum. Now, for 12th sum also, you have got a triangle given to you. A right angled triangle A, B, C. A, B, C. And you have got another triangle drawn upon AB side. This is E, where all are single line means they are equal. Similarly, at AC also you have got another triangle. This is D, where all two lines means these two are equilateral triangles. ABC is an isosceles triangle right angled at B. ABC is an isosceles triangle right angled at B. This is given to us. And let me read this problem, children. Similar triangles ACD and ABE are constructed. See, ACD, ABE, these two are similar triangles constructed on the sides of AC and AB. Find the ratio of areas of triangle ABE and triangle ACD. So, what is that they are asking you to prove? Area of triangle ABE is to area of triangle ACD. They are asking us to prove, to find out. So, first let us see. In triangle ABC, angle B is 90 degrees given. Therefore, AC square is equal to AB square plus BC square basing on Pythagorean theorem. But this means AC square is equal to AB square plus AB square because AB is equal to BC given. Isosceles means what, children? Two sides are equal. In a right angle triangle, always hypo is big. So the remaining two will be equal. These two will be equal actually. So that means AC square is 2AB square. What is AC? Let me write AC square is equal to 2AB square. Let it be like this. Now they have given that triangle ABE is similar to triangle ACD. This is given to us. Therefore, area of triangle ABC by area of triangle ACD is equal to ABE. Sorry, children, not ABC. This is ABE. Area of triangle ABE by area of triangle ACD is equal to ABE. First they told us to say about ABE. In ABE, it is nothing but AB square by ACD means AC square. This is also basing on theorem. AB square. What is AB square, children? AB square is equal to here AC square by 2. So in the place of AB square, AC square by 2 by AC square you will be writing. That is AC square by 2 into 1 by AC square. These two will get cancelled. This is 1 by 2. That means 1 is to 2. Therefore, area of triangle ABE is to area of triangle ACD is equal to 1 is to 2 is the answer for it, children. Please note it down. This is 12th one. 12th problem. Now, 13th one. Equilateral triangles, equilateral triangles are drawn. It goes on like this, children. So let me read the problem given to you. Equilateral triangles are drawn on three sides of a right triangle. Equilateral triangles are drawn on three sides of a right angled triangle. Show that area of the triangle and hypotenuse is equal to sum of areas of the triangles on the other two sides. So you have got, for a right angle triangle, the figure is not given. You have to draw, children. First you draw a right angled triangle. In this right angle triangle, they have drawn equilateral triangles for hypotenuse as well as for the other two sides. So for this side you have one equilateral triangle, and here also you have another equilateral triangle. Let me take this as A, B, C, where B is 90 degrees. So I can consider this as small a, and this as small b, and this as small c. So A, B, C, D, E, F. Now in triangle ABC, angle B is 90 degrees given to us. Therefore, AC square is equal to AB square plus BC square based on Pythagorean theorem. AC is B square is equal to AB square C square plus A square. Let us leave it like this. Now, these all are equilateral triangles. All these are equilateral triangles. So one by one we will be doing. What is that they are asking us to prove? They are asking what is RTP given to us, required to prove. What is that they are asking? Show that area of the triangle on hypotenuse. Area of the triangle formed on hypotenuse. Area of triangle ACD. Area of triangle ACD upon hypotenuse is equal to sum of the areas on the other two sides. That means area of triangle ABE plus area of triangle BCF. This is what they asked you to prove. So we are doing the proof from here. So first part we have done B square is equal to C square plus A square. Now let us continue. First you find out what is area of triangle ACD. See, ACD is an equilateral triangle. Equilateral triangle formula is root 3 by 4 B square. This is area of triangle ACD. Now, area of triangle ABE is root 3 by 4 C square. Why? Because C is the side of the triangle, equilateral triangle. This is B means this is B, this is B. This is C means this is C, this is C. A means this is A, this is A. So, root 3 by 4 side is C. So, we have written this. Now, area of triangle BCF is also root 3 by 4 A square. So, let us add area of triangle ABE E. This is E, children, not C. ABE. Area of triangle ABE plus area of triangle BCF is equal to how much you are getting? Root 3 by 4 c square plus root 3 by 4 a square. That means root 3 by 4 is common into c square plus a square. This is nothing but root 3 by 4. So here you see c square plus a square is b square. So root 3 by 4 b square. So what is root 3 by 4 b square? This is nothing but area of root 3 by 4 b square. What is this area of triangle ACD? So this is nothing but area of triangle ACD. Therefore, area of triangle ABE plus area of triangle BCF is equal to area of triangle ACD. This is the proof of this problem, children. Please write down. Now we'll see 14th problem, children. 14th one. Prove that area of equilateral triangle. Let us go through this. Prove that area of equilateral triangle described on the side of a square is half the area of equilateral triangles described on its diagonal. A square is given to us, children. There is a square so A B so A B C D is a square where each side can be considered as A units and AC is the diagonal. So upon the side one equilateral triangle is drawn, CDE, equilateral triangle. So this is also A unit, this is also A unit. And for AC you have upon diagonal also you have another equilateral triangle. So let us call this as ACF. So what is AC? First we need to find out. In triangle ABC, angle B is 90 degrees. Therefore, AC square is equal to AB square plus BC square, that is A square plus A square 2A square. So what is AC? AC is equal to root of 2A square, that is root 2A. AC is root 2A. Now what is that they are asking to prove? RTP is what? RTP is area of triangle CDE is half area of triangle ACF. For this it is half you need to prove. So let us see the proof. Area of triangle CDE is equal to root 3 by 4A square. Why root 3 by 4A square? Because it is an equilateral triangle. Okay. Now, let us see area of triangle ACF. This is also root 3 by 4. A is root 2A whole square. That means root 3 by 4 into 2A square. 2 ones are 2 twos are. So you are getting root 3 by 2A square. Now let us see what is half of area of triangle ACF. Is nothing but half into root 3 by 2A square, that is root 3 by 4A square. What is root 3 by 4 a square means, children? Area of triangle CDE. Therefore, what you can say? Therefore, area of triangle CDE is equal to half area of triangle ACF. Hence, proved. This is the 14th sum of 8.4 exercise, children. Please note down. With this, I have completed similar triangles chapter. In the next class, we will be doing the next chapter.